Hello, everyone. Thanks for joining another session. Hope you all are having a great information all day. So, our next session explores implementing continuous threat exposure management, that is STEM, as software defined vehicles and connected ecosystems expand. Static security testing is no longer enough. This talk presents a case study from Rivian showcasing the design and operationalization of a STEM program using internally developed cybersecurity platforms integrated with open source solutions to continuously validate and manage threats. Joining us on stage are Rob, who is a senior staff cybersecurity engineer who architected Rivian's advanced cybersecurity platforms, including Trails, Cyberstreams, and Fire. We have Yuso, who is detection and response team lead, responsible for building Rivian's detection, incident response, and threat hunting capabilities. We also have another speaker, Chris, who is Director of Cybersecurity Operations, leading security strategy and advanced threat management across Rivian's enterprise and connected vehicle ecosystem. Please welcome Rob, Yuso, and Chris to the stage.
Awesome. Thank you. Thank you for the introduction. And hi, everybody. And thank you for joining to hear our story and our journey. So really where we want to start, right? We're the enterprise cybersecurity team at Rivian. We're excited to share how we implemented continuous threat exposure management with y'all. And leading into the next slide, I would like to introduce you to Rivian, the company, as well as the team. So let's dive right in. So who we are. Rivian, our mission is to truly keep the world adventurous forever. We currently build electric adventure vehicles that are designed to get you out into the world and provide, and Rivian has a commitment overall for sustainability. So today you'll see our vehicles. We have the R1T, which is a truck, the R1S, which is an SUV, as well as we have developed a van that is just very utilitarian. You'll also see that we have a few new vehicles coming out. So we have the R2 and R3. You'll see the R2 and Yuso's and Rob's background. We're all very excited to share that and also share the stories of adventure with those that continue to purchase our products. So our job in cybersecurity is to protect our products, to protect our infrastructure, protect our data, protect our customers. This allows Rivian to continue to deliver on that adventurous mission. So with that, as you can see on the top right, my name is Chris Mandich. I'm the Director of Cybersecurity Operations at Rivian. I've been at Rivian for a total of 4 years now, and I lead our Cybersecurity Operations Center, our Detection Response team, our Threat Intelligence team, and our Cybersecurity Operations Platform Engineering team. That includes all the technology that surrounds our Cybersecurity Operations program. So today I'm joined here by my colleagues, Yuso and Rob, and I'll hand it over to Yuso to introduce himself.
Thanks, Chris. Hey, everybody. My name is Yusuf. I'm the senior manager of our detection and response team at Rivian. My team is responsible for creating detections, hunting for threats, and really responding to incidents. Been at Rivian also for around 4 years and really excited to dive into our presentation. With that, I'll hand it off to Rob.
And Rob, you might be muted. I'll introduce Rob. So Rob, he's a senior staff engineer. That's part of our team. He leads our platform engineering, which is all the tools and technology that we're going to talk about today.
Sorry, am I good now?
Yes, thank you.
Okay.
Anything you want to add to your introduction, Rob?
No, thanks, Chris.
Awesome, thank you. All right, so rolling into the table of contents. Like before we even roll into number one, we're going to share with you our blueprint, essentially our whiteboard of where we started this journey throughout this year. Then we're going to roll into what you'll see is preparation as well as incident response. We're focused on the NIST aspects and definitions of preparation and incident response. We want to zoom into very specific areas that we're very proud of. And then finally, we want to zoom out and show you really how it all fits together, show that continuous loop, and share the overall results we've experienced throughout this transformation. All right, so evolving security threat or challenges, and overall just our journey of how we got to where we are today. So you see across the top, we've had, like a lot of you all, overwhelming quantity of security challenges. We've wanted to focus on automated and proactive defense. And before we get to the 3 items here, I really just want to cover, again, like we're aligned to NIST in order to prepare to detect, respond, as well as recover to cybersecurity incidents. We've aligned our entire program, both at an enterprise level, but additionally within our cybersecurity operations program across NIST, CSF2, as well as the latest guidance that they have provided. So Rivian has truly created, unfortunately, due to the rapid scale we've grown at, 3 critical security challenges, which include inconsistent defense, scalability challenge, as well as manual bottlenecks. So leaning in on inconsistent defense, that's actually for us inclusive of both the scalability trap as well as manual bottlenecks. We'll provide that just overall throughout this presentation. For the scalability trap, right, we've seen in the last 5 years and beyond over 30x increase in the data volume that we're receiving. And like when I had joined, we were at roughly 150 gigs of data per day in our SIEM solution. We've actually graduated now to a little bit over 10 terabytes of data persistently per day. We essentially overwhelmed our traditional SIEM, which led to a crippling quantity of alert fatigue, as well as the manual bottlenecks, which we talk about next. When it comes to manual bottlenecks, right, due to that overall volume, our analysts were drowning in repetitive tasks. Investigations became slow. Our mean time to resolution was far too high. And then finally, this overall led to that first bullet, which is inconsistent defense. So our periodic assessments continuously left gaps. Our manual workflows were impossible to scale effectively. And with that, we'll jump right into that blueprint and get kicked off with preparation, which I'll hand over to you, so.
Awesome. Thanks, Chris. So starting with preparation, for us, really preparation isn't a static checklist. It's a engineering-driven, threat-optimized approach that we take. We want to ensure that our detections and our tools are functioning as we expect, not just when we build them and ensure that they're working properly, but what does that look like as our environment changes? As our business evolves, we want to ensure that we can still have that. But before we dive into all of the details around simulations, I wanted to take a step back and take a look at our blueprint and really show you guys and document really the scale that we were working with. So in the next slide, this is really what we came up with. So earlier this year, we sat down and whiteboarded and wanted to document that scale, wanted to brainstorm some solutions so that we can understand how can we most effectively solve our challenges. We quickly realized that we were getting around 3 billion events into our data lake per day. That's consistently been growing. That continues to grow today. As more and more events are coming into our data lake, that's generating more and more observables, more and more security events of interest that we'd want to alert on or detect on. They eventually make their way into alerts within our systems. Those alerts will get correlated. Once those alerts are correlated, we'll actually surface that case, and then that case will get responded to by our team. Today in this presentation, we're going to really be diving into 2 core pillars of it. It's going to be Eddy. Eddy is our correlation engine. That's where we build our detections and surface those threats. Rob will dive into those details in a little bit. We have Gen AI. That's really an enrichment augmentation for our case generation. It allows us to add more context to our cases, allows our analysts to get all of the information that they need so that they can be successful in their response. Our automation response kind of arm is going to be within playbooks code. We will dive into more details around here, and in this conversation and presentation, we'll be sharing how we leverage searching within that functionality, but we really built this platform in a way that's modular, so we can add other things within our playbooks that we want to achieve. So in this example here that we have, it's going to be group actions. So after all of the things that happen within a case, you might want to perform some actions for that case in that context. Those are going to be our group actions. So if you need to isolate a device, that's where we kind of capture those. But when we're talking about any type of automation, we also want to have some oversight. We want to ensure that when we're making impactful changes to the business that can disrupt something, we want to make sure that it's appropriate. We want to make sure that has some type of review. So that's when we go into our decision block. In our decision block, that's where we allow the team to have peer reviews. So different type of group actions that might be less impactful, like let's say rotating a session that has low impact on the business, but great value on the security side, we can allow that to be peer reviewed by some other analysts appeared in our team as they're working through those cases. Then we also have privileged users in the loop. Really here, we want to have oversight over more impactful actions and ensure that we are doing it consistently, ensure that it's the appropriate action to take, and that allows us to give leads the opportunity to review those actions, allows managers to review those actions, um, and really just ensures that our system is operating as expected. All of our group actions are really going to be built from these smaller building blocks, which are those atomic actions. Depending on your environment, you might have one tool that isolates all of your devices across the board. In other environments, you might have multiple tools that would need to be involved in that process. For that, we really build those up and bubble those up as group actions. So now that I've shown you guys a little bit of our blueprint and zoomed in here, how do we make sure that these systems work? When we put them in place, we know they work because we just deploy them in production. But how do we know, again, as time goes, that these systems are still functioning as we're expecting, and that that we don't have any errors? So for that, we're going to dive into our simulations. And really, this is what our at a high level what our simulation process looks like. It all starts from inputs. So here we'll have inputs from different cybersecurity programs. It might be our red team, it might be our incident response team, it might be tied to whatever thing that might be happening that will inform our scenario creation. We also have threat intelligence. So this is where we use the latest threat intelligence that's tied to our industry, tied to our business, tied to the things that we care about, and that helps inform those simulations. Once we have all of that data to help craft what that simulation would look like, we leverage a breach and attack simulation tool called, or a BAS tool. In this case, for us, it's an open source BAS tool called OpenBAS. It's really a simulation engine. So it allows us to emulate threat actor TTPs. It allows us to emulate different type of behaviors that we're interested in testing. And that gives us the power to go and then test our detections. So we follow detection as code philosophy at Rivian, which means that we have all of the great things that come with detection as code. We can validate all of our detections are built in the appropriate way, follow our existing process, work when they get deployed into production. What we were missing was what happens when time changes, environments evolve, security controls get put into place. How do we know that that detection that we deployed a year ago is still functioning as we're expecting today? So that's where we put in our OpenBAS tool. It's able to simulate those activities and then surface any issues proactively for us, and then we can really focus our engineering efforts. What's also really cool with all of our platforms is we really follow that engineering approach, so everything can be done all at once. As you're building a detection and you're understanding the threat that you're trying to surface, you can build that simulation that would emulate that threat. It allows you to actually test your detections with actual events within development as you're building it. And then we're also able to ensure that our playbooks as code are functioning as expected. So we'll dive a little bit deeper in a little bit on our playbooks as code, but we're able to simulate our playbooks as code. But that's not all you can do with the BAS platform. You can simulate your security controls. You can ensure that the controls that you have in place that you're expecting to work continue to work as the environment changes. And all of these different simulations will provide data. So we take that data, we put it in different dashboards. It gives us a nice view of our readiness in our preparation phase. It gives us confidence that our systems are functioning as we expect, and also gives us the opportunity to create alerts if we see things that are breaking or we want to catch things before they become a big issue. Really, that allows us to ensure that we're always at that constant state of preparation. It's not, again, that static checklist. So that really covers what our simulations look like. And after you leave the preparation phase in NIST, we go into more of the active phases. With that, I'll be handing it over to Rob, who will dive into the next stages of NIST and really dive into detect.
Thanks, Yuzo. So what we want to do in these next couple slides is really set the foundational basis and show you a little bit of what our tools are doing and what we built within our cybersecurity org here at Rivian. So as Chris mentioned up at the top, like we had a lot of scalability issues that we were facing with our tools, our technology. So what we wanted to do is take a completely like fresh approach to building tools and managing tools for our cybersecurity organization here at Rivian. So with that, we can talk left to right. What I'll talk through is how we collect all of our data, how we get our data into our data lake, and then how we detect on all of those items. So on the screen, you can see we're collecting logs from tons and tons of different data sources. We have SaaS logging, we have internal applications, and then we also have our entire OT environment because we're a manufacturing company. So we need to be able to collect those logs however possible, whether those are syslog items forwarding us the actual logs, whether it's APIs that we need to go up and collect the logs. Um, we wanted to make sure that we really had a foundational basis to get all of those events to our security data lake as fast as possible. So what you'll see in the middle is our platform called Streams. Streams is a in-house built containerized platform that we leverage real-time streaming to get those events in a landing zone for our data lake to consume as fast as possible. So you can think of this as a lightweight container-based system, and we use Vector, which is an open source platform, to collect those logs. It has all the connectors, so think about like traditional Splunk HEC, think about TCP, UDP, all of those kinds of inputs that you would need to collect logs from, and then push those out into a landing zone. So we really make sure we can label all of the logs properly, format them properly, get them in a place where they're easily consumable, and we move the data as fast as possible. So on the right there, you'll see Trails. So Trails was our step back at really taking the opportunity to scale with the amount of data that we had. So we took an approach and moved to a data lake platform, and we chose Databricks. And there was a couple of primary factors on that. And like as we've mentioned, we've had endless scale going from 300 gigabytes to 10 terabytes. And so we really wanted to move away from those ingest-based licensing models that didn't allow us to scale from a cost perspective, and we wanted to really make sure that we maintained like our data and making sure that we can keep it at a low cost, but we can scale infinitely whenever we want. So what Trails is ultimately responsible for is housing all of the data so that our detection engineers, our incident response, our threat hunting teams can go find whatever data they need whenever they want. So what it looks like is we receive events from upstream log sources, and we make sure that we stream all of those events into what we call refined source tables. So think about, we have a collection of tables for our VPN logs, we have a collection of tables for our IDP, all of which are normalized. We add observable sticks, observable objects to each individual row as we're collecting each one of those events. And then it's all housed in one centralized location for anybody across the organization to come and find the logs that they need and be able to do all of the engineering activities that we do. So with Trails, we set up a few foundations that expanded past our traditional SIM tool that we had. So we enabled real-time detections, and then additionally allowing for a little bit more correlation across multiple tables. But what it really what we found is that moving to a data lake, you do have to work in the world of SQL. So in the next slide, what I want to talk through is our next phase of how we detect. So this was an additional, I'll call it another step back for us to really conceptualize how we can use all of the data from all of the data sources that we're collecting. So we have tons of different log events. We have over 100 different data sources that we're collecting data from. And what we're really looking for is some way to say, hey, these specific events from our say our VPN logs and these other events from our IDP, those are more interesting security events that we're actually interested in. Maybe some of the other events are just noise that like it's there for a reason, but we may not need them as doing security investigations or writing detections or doing threat hunts. So what we did is we took an approach to take all of the logs, no matter where they're coming from, and we're streaming them all into one consolidated table. With that table, what we ultimately decided is to go with one common data model and schema for all of the events. So you can think of these things as what we call them as observations. So those observations, what they look like, they have a title, they have a description, they have an entity, which is like the primary actor, and then they have an object, which is the object that that entity took action on. And then we can also expand that data model to include any other additional metadata that comes from the raw log event. But ultimately, you could think of this as one consolidated table that has all of our security events in it. And the security events that we deem as, hey, these are things that people would find interesting in writing detections, doing threat hunts, investigations, all of our cybersecurity activities. So when we talk about like NIST detect, really what we're looking for is a way to take all of those events, all of those security events, and build a story. So now that we have one common data model, we can take all of those events and correlate them together. So it doesn't matter if it was VPN activity or coming from another data source, we can really take those observations, define a story, and say these all of these events together constitute to open an investigation, open a case, send an alert to an external team, whatever it may be. So really, like, this has enabled us to take endless amounts of data from any given data source and put the picture together and make sure that we can correlate across all of our data in our entire security data lake. So next is a little bit on the right. So we can talk through how we deliver those alerts, what we do with automation, and what it looks like to actually deliver those alerts to investigators and that continuous testing that Yuso was talking about of actually generating alerts from our detections. So the next platform that we want to talk through that is Fire. So Fire is our automation and orchestration event platform that we've built out, and it serves two main purposes. On the left, you'll see how Fire is integrated into that end-to-end process of collecting data, housing the data, detecting on the data. But ultimately, we have tons of alerts being generated, and we need to get them into the proper place. So Fire Alarms, which is our module that actually sends out the alerts, is an event-driven architecture that we can receive the alerts and move them as fast as possible to wherever they need to be. So think about notification services, whether it's like Teams or Slack, or putting the alert in our case management platform. Maybe it's just an informational alert, or maybe it's a critical level alert that we need eyes on screen as fast as possible. So Fire Alarms is ultimately responsible for putting those alerts in our case management tool and then also paging other investigators, incident responders, if well, depending on the level of those alerts that come in. It also enables us to send what we call cross-team alerts. So cross-team alerts, what they ultimately are is an alert to an external team that we help facilitate, but ultimately those external teams are helping with that triage process. So some of our external teams have more context on the activities that they're doing day to day, and they can inform us on whether or not they were actually legitimately doing that activity, or whether or not, like, hey, we weren't doing that. You need to escalate this, and we need to bring in cybersecurity to investigate this further. On the right side, you'll see our Fire Ranger module. So I'll hand it off to you so in a minute, but just to explain what this serves for is Fire Ranger is also a container-based orchestration platform that we use that we've opened up to our entire security organization. Think of it as a SOAR platform where anybody can come in, they can build any workflow, they can build any automation, they can run it on an ad hoc basis, they can run it on a scheduled basis, but really allowing our entire security organization to build whatever automations that they want, come into one centralized repo, use our standard templates, and build out, yeah, really whatever they want. But what we're ultimately using Fire Ranger for as well is our true orchestration tool for our playbooks as code. So you'll see firefighters on there. That's our automated playbooks. That's just our internal name for it. And you'll see there's a theme across all of our tools that we have here. But firefighters runs on inside of Fire Ranger, and it allows us to automate the the playbooks as code, but it also allows us to asynchronously kick off all of these tasks that we talked about from fire alarms. So when we have an alert come in, if we want to run playbooks automatically, we can open a case as fast as possible and then asynchronously kick off all of these tasks to run and all the playbooks to run. So I'll hand it over to Yuso, and you can zoom in a little bit on how those playbooks as code work, what they look like, and how we're using them.
Awesome. Thanks, Rob. So Rob showed us how we take those billions of events that are coming into our data lake and they make their way into a case that actually gets responded by our team. But before we dive into how this is all functioning, I wanted to take a second to talk about why. As Rivian was scaling, our cases grew. We needed to keep up with that scale. So we started trying to define what would that really look like. That's where we started getting ideas for our playbook as code. It allowed us to take this increasing MTTR that we were experiencing and start decreasing it because we can start automating some of those response actions that we were doing manually before. We were also growing as a team. We were building an in-house security operations center. We were hiring a lot of different analysts of various skill sets, and we wanted to ensure that we had consistency across our playbooks. We wanted to ensure that we had some consistency across our notes to really make it easy for us to be able to share that across the team and understand what the response is for any type of case that we're working on. And really, what ultimately happened was that our processes that we had before just weren't scaling with Rivian. Rivian was scaling faster, and we really needed to catch up with them. So we built our playbook engine. We wanted it to be easy to use, easy for the team to be able to contribute to it. So we defined it all in YAML. It's human readable. It's already something that our team's familiar with because we're doing detections as code. So we decided, hey, we can do YAML for our playbooks as code as well. This allows us to leverage all of the great things that we already had within our detections as code. We already had tests that we were doing in our pipeline as those were being deployed. We had peer reviews. This allowed us to take that same approach for our playbooks, allowed us to make sure we have that oversight. We were able to kind of share that with the team as we're deploying them and ensure that we have that consistencies on our playbook, and not just the playbook that was documented somewhere in a documentation repo that was viewed every once in a while, really depending on the analysts that were working on it. So let's dive in a little bit on how that actually works. It all starts from a trigger. So the trigger will be that case that gets created. Whatever the data that preceded that, eventually that case gets created and our playbook engine will pick up that case. It will assign the appropriate playbook to that case. So if it's a malware playbook, it'll assign the malware response for that one. If it's a phishing one, it can assign the phishing playbook. It really allows us to be granular and customize our response on a case-by-case basis, on a detection basis. Next, we have our search executions. So really, today we're going to dive into how searches work, but this is where our modularity for our playbooks comes into play. This search step that we have, or really our steps within our playbooks, can expand into different actions. Things like those group actions that I mentioned before are ways you can do it. You can tie it into communications if you want to have that outreach happen when a case gets created, and take that feedback in as you're building these playbooks as code, and really allow you to define all of the actions that you would do as part of a response to a case, and then automate all of those actions in a modular way that's easy to consume. All of those actions that you would take, the searches that you would run, they would all have results. So we wanted to, again, make sure that our cases were enriched appropriately. We wanted to make sure that we had that same consistency across all of our analysts as they were working on it. We wanted to all understand, hey, when we took that action, these are the results of that action, and we can be confident that we have that audit trail within our case platform. So if ever we have to go and review our cases, it makes it very easy for us to understand what happened, the actions that we took. This also allows us to really share cases, and allows the other team members to pick up cases when someone had to move their shift, or something happened and they needed to hand off their case. All of that information is documented in a very standardized way. We're really only limited to Markdown, which is what our case management platform supports, and we can craft and format all of these as we choose, and it's very flexible. So now that we have an idea of how it works, let's kind of dive into what that actually looks like. In this next slide here, we'll be starting with our searches. So at the top left here, it's a really zoomed in view of the smallest building blocks to our playbooks, especially when it comes to our searches functionality. This is going to be our searches YAML. We have a lot of metadata here that's really not defined, but really the core of our engine and core of our searches is the zoomed in view here. It starts with searches. So this is going to be the SQL search that we actually execute across our data lake. We can leverage this to run multiple searches at one time, scale, and kind of keep up with all of the cases that we're creating. But we also wanted to make it a little bit dynamic. So instead of just running searches that might be more broad, we can be a little bit more surgical and dynamic in the way that we run our searches. So what we do is we can take the observables that are tied in our cases and take that context and put that in dynamically into our searches. So if we have a case that's an identity case and it's looking at my user account, when that search executes, it'll actually add that user into that search at search time, giving us that enrichment in real time on whatever the activity is for that user. Following our searches, we also have something called arguments. Arguments are really those common things that we want to be able to manipulate across all of our searches. Today, we use it for time. Pretty much all of our searches have some time-bound look that we have for them. We can define that here. This allows us to have searches that have defined times. So in this case, it's 7 days. Moving on, we have tags. So sometimes you might want to execute a explicit search because that's exactly what you want to get back for your case. Other times you might want to group searches in a logical way. So we leverage tags to be able to run multiple searches at the same time. We leverage it in a way to logically group our searches, and it also allows us later when we call those in our playbooks to be able to expand them. So if we have things like fundamental searches that are looking at users, and we might have a set of fundamental searches for that user observable, we can expand that if tomorrow somebody thinks of a new one and they're like, hey, this should be a fundamental search. We don't have to go and update all of our playbooks that might be using this. We can just do it at the search, and our playbooks would pick that all up. But tags don't only have to be tied to fundamental tags or anything like that. It's really any type of way you can logically group them. So you might have different threat actors, behaviors that you want to tag within our searches, so that you know that if you're looking for that threat actor, here are all the different searches that might surface some activity or TTPs for that. Following our tags is going to be our messages. This is where we can really craft what our case management results look like. Here in this example is just a very simple string. It also allows to take those dynamic variables and puts them into our case at execution time. But again, we're really limited to only our Markdown language. So you can imagine that however you want to define your message to be shown in Markdown, it would support that. And then the last two there are really just some table references where the search is going to be executed, and then a flag to allow us to say, hey, do we want to pass the SQL search into the case or not? We have the ability to choose that because there are some searches that don't necessarily need to go into a case. It's unnecessary. We don't dive into that data set as much. For others, we're able to toggle that as we choose. In the bottom left, that's going to be a zoomed in view into our playbooks. So really, again, it's looking at the core functionality of it, and that's going to be steps. Here we have two different steps within a playbook. You can continue chaining these as complex as you want, loop in different types of actions. We just wanted to show a very simple example of two different searches and how they would execute. They both will have names and descriptions. This gives us the ability to understand what's the purpose of the step, some context around it, give it some color, ensure that when we're pre-reviewing it, we understand what the functionality of that step might be, what it's trying to achieve. And then after that, we go into our step function. So this is where that modularity comes that I've been talking about. Here, we're explicitly defining this step as a search step so that it's going to use our search as YAML. You can expand that into group actions, communications as you choose. It's really based off of your operations and how you function and the needs of the business. After that will be the actual search that gets executed. In the top one, we're running an explicit search for a explicit search in our catalog. In the bottom, we're leveraging those fundamental tags. So this allows us to take, just two steps in this example playbook, but it can run an n number of searches as part of that. It helps keep our searches nice and clean. It doesn't clutter them, they become really long. It makes it easier for us to review. And then after that, we have our arguments, similar to how we have it within searches. So our arguments here allow us to override our searches arguments. Sometimes you might have a playbook and you don't really care about that timeline. What we have as default works appropriately. Other times you might want to say, hey, for this specific case, I'd like to actually search 30 days, or I'd like to search for 1 day. It really allows us to override whatever that search timeline is on a playbook by playbook basis. So we can have multiple playbooks looking at the same threat in different ways, and really allows our analysts to be able to be confident in our kind of response as we're going from there. Then on the right, we have our cases. So we wanted to show a very simple example of what it looks like when it comes to our case and how those notes get reflected. And I really want to dive into just two aspects of it. It's going to be how our search results come in, and the other is going to be how we pass along our SQL searches. So starting with our search results, we quickly understood that we don't want to put all of the results of our searches just inside of our notes. That can make our notes very long. You can imagine that there might be searches that return a lot of results. It wasn't feasible to just have that be pasted as a table because you might want to manipulate that data, and it makes you have to scroll a really long time. So we wanted to figure out a way of how can we do this a little bit better? How do we make it easier for the human to read and review to best understand what's happening? So we decided to set a limit. If our results breach that limit that we set, it would actually attach it as a CSV. The note would look slightly different. It would point the analyst to that CSV. They can then download it and really analyze it as they see fit. In the bottom is going to be our SQL searches. So the really cool part about this is sometimes you might be working a case and you see a result and you want to dig deeper. So instead of our analyst having to go and shift over into our repository, identify the playbook or the search that was ran, we expose that directly in the notes within our case. This allows us to take the exact SQL as it was ran with all of those dynamic fields that were added to it. You can paste that into our data lake and continue on your investigation. In those cases, you might pivot deeper, dig deeper, whatever your investigation requires you to do, you're able to really quickly pivot over and continue that investigation without having to pivot into other tools. And this really covers our playbook engine, covers how our playbooks and searches as code works. But this really isn't the only benefit, or our only benefit isn't just for our operations center or working from a case got created and then we have this response. We're able to trigger these playbooks in an ad hoc manner as well. So we can manually trigger them when we choose. So a lot of benefit that we found as well is going into our incident response team, going into our threat hunting team. We're able to take our incident response playbooks and not just have them be defined and be an appendix within our IRP that gets reviewed on a periodic basis. We can actually transform those into playbooks. And then when we have those types of incidents, it's very trivial for us to at least speed up our incident response processes, speed up that analysis that it would take for us to respond and resolve that incident, because we can then just kick off whatever those playbooks would be. And similar to within threat hunting, we can take that same approach. We can build hunting playbooks that allow us to gather our data faster, repeat our hunts more consistently, and really share it across our team. So we found a lot of great value from building tools like this. And with that, I'll hand it back to Chris to close it out.
Awesome. Thank you, Yuso. Thank you, Rob. So thank you for zooming in and into some of the details there, Yuso. So now we want to focus on like truly zooming out and looking at what does this mean for Rivian? What value has that provided us overall? So like first, like want to like reflect, we showed you the blueprint. Now, like this is the big picture that we've been building together throughout this presentation. This is what our entire ecosystem for cybersecurity operations look like. So if we kind of dissect this overview on the left-hand side, you'll see a list of our in-house tools that we've built. Each of those are highlighted in purple throughout the graph or throughout the diagram. Across the blue, you'll see from NIST the phases of incident response, so detect, respond, and recover. Towards the bottom, you'll see in green the phase of preparation. And then in the center, bringing everything together, you'll also see that there's lessons learned. We're continuously improving based off of cybersecurity incidents, external learnings, other programs, other teams throughout Rivian and throughout the industry, and like really providing that feedback loop overall for our cybersecurity program. So if we walk through detect, as you heard from Rob, we start with streams, right? So that's our solution to the scalability trap that allows us to handle large volumes of data and then refine those data points throughout trails to then allow us to successfully correlate with Eddy. And then finally, send a notification directly to fire alarms. In the top right-hand corner for respond, this is in recover, this is our solution to the manual bottlenecks, as well as a consistent event. Fire Ranger, our playbook execution engine, as well as firefighters, our overall automated playbooks. Those allow us to ensure that we can have the speed. We also have the consistency to continue to perform incident response as well as cybersecurity operations effectively throughout the organization. And then finally, on the bottom right, we have our virtuous cycle of continuous improvement. So we receive input from cybersecurity programs, we receive input from threat intelligence, receive input from cybersecurity incidents that we chatted about earlier. We feed that into our behavioral or our breach and attack simulations, and that allows us to continuously validate our detections, our response capabilities, etc., throughout the team. And then finally, our foundation is all built off code. So this allows us to effectively scale as a fairly small and nimble team and continue to grow as a business through that foundation of code, both from detection but playbooks, but also the entire infrastructure around the system is all based and built off of code too. So to close this out, like Rivian has truly changed challenge and turned it into capability. So our solution for the overall scalability trap that historically was drowning us, we've learned to master both the scale that we received and affordably process massive amounts of data and turn it into a handful of priority cases for the team to focus and zoom in on. When it comes to inconsistent defense, right? Historically, very manual, there were a lot of inconsistencies related to how we responded to cases. We've transformed that into truly data-driven validation through these automations, where we can empirically prove that our security controls continue to be effective against threats and large-scale threats. And then finally, our solution to manual bottlenecks that have historically slowed us down is truly the automated response around our ecosystem. So this allows us to investigate and contain threats in seconds and reduce our overall mean time to resolution throughout the organization. Finally, that wraps us up. So really want to say a big thank you to Yuso and Rob who joined me to talk about all the excellent work that they have performed as well as the team has performed here at Rivian. And thank you to Secure Our Streets for hosting us today. And thank you to you all as the audience.
Well, that was a great presentation, and the path takes is a tremendous job, and it was fantastic. Thank you for introducing us. And then, so we have some questions. So one question we have is Fire something you built or bought?
Yeah. So Fire for us, it's one of the many internal applications that we built. We had We've historically tried to be creative with solving security challenges differently, both to ensure that we're cost effective, but also to get it integrated with the large technology that is in-house built at the company, right? A lot of our stuff isn't natively built into commercial products. Therefore, a lot of the integrations we've historically built for commercial products have been custom development. So therefore, we took a step back and tackled both lowering our costs, but also improving capability and integrations throughout the business. And you'll see a lot of that has been built into Fire as one of the tools.
Amazing. Okay, I think we are on time. Thanks. Thank you for the presentation. And for any participants, if you have questions, the speakers will be available in the lounge so after the session. So you can jump in and have a chance to talk and ask your questions. And thank you, and have a great day.
Awesome. Thank you all.